Hi, it's Mr. Mabry, and we are going to take some notes on physical and chemical changes. You will need your science notebook and a ruler because this is how you want to set up your notebook. You're going to need to make a half-page grid. This should be underneath the title. This should take about half a page down. One column for physical changes and one column for chemical changes. We'll put definitions here, a guiding question, and then we'll do a couple slides with some pictures as examples. So you can go ahead and pause the video if you want and set up that grid. Again, it should be about a half page total with the majority of the room here, maybe double spaced here and here. Alright, let's talk physical changes. A change in a substance appearance. That's all a physical change is. It's like when you decide to come to school and you're going to do your hair a new way, do that new makeup, or do that new look. That's a physical change. I rip a piece of paper in half. Rip. Physical change. Not very exciting. Compared to a chemical change, this is where we make something completely new. Notice how I've italicized these right here. These are your key words: new, substance, and appearance. I would highlight those or underline them. So your key question when talking about these is something still blank? Is a car still a car? Is a marker still a marker? No matter if I do this, still a marker, just looks a little different. Now it's two pieces. That's your question for physical change. Is blank still a blank? Compared to chemical change, where that question would be, hey, do we make something new? Surprise, science magic, it's something new. So let's do some examples. What's this? Ta-da! Statue of Liberty. It's beautiful. It's green. It's copper? Weird. This is the old color of the Statue of Liberty. Here is the new Statue of Liberty, the one you and I have either traveled to or wish we traveled to. Now you might be thinking, this looks the exact same. This is one color, this is the other, but it's still the Statue of Liberty. Haha, I've tricked you. This is an example of a chemical change. Not because, yes, the Statue of Liberty is still the Statue of Liberty, but this green thing is something called tarnish. It's a new substance where the atoms in the air interacted with the copper atoms and it made a new compound, a brand new substance. And if you could scrub away the Statue of Liberty, you could get back to that copper color. But nobody does this because it's going to quickly turn green again. Tricky. Let's do another one. Here we have a normal looking iron nail, and here is a rusty nail. So is it still a nail, or did we make something new? And again, I did this one because it's slightly tricky. This would be an example of something new, because rust was a new substance we put on the nail. So though the nail is still a nail, the rust is something new. All right, here we go. We've got a piece of ice, and we've got a puddle. So is ice still ice, or is this something new? And I know what you're thinking. Aha, it's something new, just like the last two. Well, no. Melting water is still water. This is water, and this is water. This is water in one form, and this is water in another form, but water is water. There's no new atoms. There's no recombining of things. There's no new compounds being made. This is H2O and that's H2O. So these would both be examples of the same thing. Now imagine you're starting to think, man, this is harder than it looks, Mr. Mabry. How am I going to get these questions right on a quiz? Well, let me give you some hot tips. Why don't you add this box right here in your notes? How do I know when something new is made? You want to look for these signs. You're looking for new colors, new smells, maybe a solid has been made, like a powder, like the rust, or maybe it's going to get hotter or colder. And remember, if we make gas, if gas is made inside a liquid, you're going to get bubbles. Very exciting. Don't worry, we're going to do a couple different activities to practice the use of these chemical and physical properties interacting with each other to do physical or chemical changes. So why don't you put those notes away, and now let's do something fun.